In this video, we gonna talk about Manchester line coding. If you think we gonna talk about football clubs, you can escape right now. Now, what is Manchester line coding? Before we explain the Manchester line coding, we should understand what is a line coding. So let's begin. Are you ready? Are you sure? Let's go! This is a line coding. Oh, unfortunately, it's nothing. It's just a picture. Let's simplify the idea. When you travel to China or anywhere, and you don't know the language they communicate with, what you should do? So a message from a Chinese person is decoded and encoded by a line coding to another person. So line coding is like a translator who lets the other who have another language understand your message or your language. So let's go to Paris. Your message is an analog signal which varies from amplitude. Let's go to a channel that have a line coding, some of line coding types, to a device. So line coding is the process of coding a message to transmit as clean as possible without having an intersymbol interference, which is a simple form of a noise. For example, when you say hi, you put it how you translate it to in your WhatsApp. So hi is coded by the keyboard into a set of bits. So don't be confused of that. But we have many types of line coding. How you can choose? It's represented by symbols 0s and 1. Line coding. We have unipolar, polar, bipolar, and we have even more. Like NRZ, which is non-return to 0. It means a signal varies between plus and minus, plus V or minus V. A 1 is represented by a G, a pulse, where 0 is represented by the negative of the pulse. Bipolar NRZ is also known as alternating mark inversion. And what I have said, that's only the beginning. So let's begin deeper. In alternating mark inversion taking place, the successive first one are represented by a pulse with alternating polarity, and they are represented by a no-pulse. Now let's talk about unipolar RZ. Return to 0. It's generally meaning that it's return to 0. So it's from plus V and 0. So it's generally between 0 and 1. Now let's talk about bipolar. From its name, it have two poles, and it uses free amplitude levels. Positive or negative pulses of equal amplitude are used alternating for symbol 1 and for symbol 0. Now let's see this example. So at the first one, it's a V. It's half the duration. Now we're gonna talk about the best line coding technique that we're gonna cover, Manchester line coding. Manchester line coding is a very commonly data used. It derived its name from the development at the University of Manchester, where the coding was used to store data on the magnetic drum of the Manchester Mark I computer. So Manchester line coding is about averaging the high and low pulse duration of the complete encoded data. So let's draw the schematic to understand it more and more. Symbol 1 is represented by a positive pulse. So let's begin. If at 0, it's a falling edge. It's from high to low. Where at 1, it's from level low to a level high. And at 0, from high to low. And the second 0, from high to low. And from 1, it's from low to high. And the second one is from low to high. And we continue. It's a matter of sequence. Symbol 1 is represented by a positive pulse, followed by a negative pulse, whereas symbol 0 has the opposite of the first one. It is reversed. Pulse code modulation can be used to convert analog signal to its digital form. A pulse code modulation, it is a combination of sampling and quantization, which is sampling is taking every sample time at a specific time. Pulse amplitude modulation is a form of signal modulation where the message information is encoded in the amplitude of a series of signal pulses. Now you have seen in the graph the message that we are sending. Pulse code modulation (PCM) is a method used to convert an analog signal into a digital. Now to calculate the power spectral density and the bandwidth of the Manchester line coding Manchester signal, we have to get the mean and the variance of one pulse because every pulse is a sequence of the another. So we need to know some variables to get the mean and the variance. So first, what is a random variable? A random variable that has a specific value at a specific time over a non-continuous time domain. We need to know some variables here to get. We first get the mean, now the variance. Variance, it's represented by sigma square. Xi, we explained before. In case of the Bernoulli random variable, which is a numerical or calculus course, however you take it, the equation is below, which represents the mean for the main part, power spectral density, which we are measuring the power of the signal versus the frequency. It can be calculated as the follow: the power of the one pulse times variance square. Variance, it's not square. Variance, it's always a square. Sigma square plus mu square. Rs, which is the mean square when it's not big, s equal as 0. If we see we plot Rs. Now we are talking about the general equation for Manchester. Finally, we are talking about Manchester.